Yeah, and of course, thrilled to be here with all of you today. And before I start my talk about quantum sensors, I want to share something, in a sense, also personal. And I remember 1 year ago, I was seated over there. I was an attendant to this gathering. And I also want to personally thank Fernando, who brought me here, to Juan, to Marce, to all the team of the foundation, and of course Raquel. And I remember being sitting there and thinking, one day I want to be in the big table. One day I want to talk to people about quantum. And here I am. So let's talk about, after this introduction, about quantum sensors. Why are these important? And to your point, Scott, yes, we will be also discussing defense applications of this. I will be focusing mainly on the civil side of things, but of course there is, I would say, strong impact in the military sector and defense sector, and they are definitely interested in this. And this will lead us, and I will also thrilled to hear some insights for you, Ted, about the ethical implications of all of this. So now, what is a quantum sensor? And a quantum sensor at a very high level harnesses the power of quantum mechanics so that we can measure things better. And how can we transform this from an experimental demonstration to a business application and to industry applications? I will be speaking about 4 main areas where we believe it's where we will start to see real business value in the nearer term. I prefer saying nearer term because it's difficult to speak also in time frames in this technology. So I will be talking about navigation systems. And I'm also thrilled to have here Antonio Abad from ISPASAT, and he knows a lot, certainly much more than I do about navigation systems. Then radars, and we speak about quantum radars, and also imagining with medical applications. And I remember, Mark, you were one of the first individuals who taught me about this, and I will be using the insights you gave me so generously. And last but not least, I will be speaking as well about gravitometry and why, and this is also a fascinating question for me, why, for example, what is the relationship between quantum gravity, for which we don't have a theory, and maybe we will need to go through the string theory. I'm talking now about something very abstract, and how we translate that into an application for business. And this also ties with the idea of why researching in fundamental science is critical. And then the challenge there is how we transform that into value for businesses, societies, and so on. So the first point is navigation systems, right? And navigation systems, classical navigation systems, have a series of problems in terms of vulnerability and in terms of viability. This is concerning because we use navigation system pretty much for everything we can think about. Now, using quantum technologies, it is thought that the security and the accuracy of these systems can be achieved. And for example, the European Space Agency is working in this realm. Then, closely related to this is the concept of a quantum radar. Again, classical radars, at best, are able to determine the approximate position of an object and its speed. And now that is clearly limited. So a quantum radar, which uses a concept called quantum illumination, and this concept was pioneered by scientists and researchers at MIT, obtains a much higher degree of accuracy, so we can tell which object it is. And that is also very important, and which objects, and more precision in terms of position and velocity. And then moving on to the let's say, medical field, we were discussing before about measuring the magnetic fields. And it turns out that we humans generate magnetic fields, for example, in our brains. And those magnetic fields are notoriously difficult to measure. So, for example, in the unfortunate case of brain cancer, we are not able to detect the tumor itself, but the damage around the tumor. And then the machinery for doing that classically is bulky, expensive, not portable. And there are, in the UK, University of Nottingham, if I recall correctly, that they are working in quantum sensors for doing wearables, machines for MRIs. So now they are portable, and they are also easier for certain patients, for example, children. And last but not least, the relationship between quantum gravity and businesses. So if we are able to measure gravity in a better way, we will be able to, for example, discover oil reservoirs or gas reservoirs. This is also potentially, I wouldn't say a solution, but an alleviation of the current energy crisis. And British Petroleum is one of the companies working in this realm. And those are tangible examples of how these apparently ethereal and mathematical concepts turn into business value. Now, what are the challenges of all of this? Well, there are technical challenges and business challenges. From the technical perspective, quantum sensing in general are very nascent technology. I would say more than computing and more than communications. So parts of it, if not all of them, are still in the experimental demonstration phase. However, despite that being discouraging, I see that as inspiring to continue moving forward. And then these kind of sensors have problems in terms of robustness, noise, these kind of things, and they also need to operate at cryogenic temperatures, which is, of course, an issue. And from the business perspective, as Brian was correctly pointing out, Rome wasn't built in a day. So businesses need to adapt their protocols, their infrastructures, their production system to all of this, and this is far from trivial. And then, again, and now I will be using the last minutes of my intervention, now we also start to enter into the ethical and the laws realm, because we really don't have the answers and the laws to address this. Like, for example, if a nation has quantum radars, that nation has an edge over others who don't. How do we legislate the proliferation of these technologies? That's the case. How do we ensure that everyone has fair access to these technologies, and so that they are used for the good of all of us? And this also relates to of course, the military applications of all of these. In the case of navigation systems, those who know more accurately where they are, and knowing where we are is a non-trivial problem, have an edge over the others. And what do we do with those who, in a sense, don't comply? So those are non-trivial questions. Those are a non-trivial question and not technical questions. Those are ethical questions that hopefully we all together will be able to address. And that is why I also believe that in this field, we need all the brain power that we can gather. And that is why I'm so thrilled to be part of this group, for many reasons, but because I see people here from all walks of life, working together, learning together, and hopefully at the end of these 2 days, we will have an actionable plan for these technologies and for us to move forward. So with this, I end my intervention, and hopefully it has been as informative and illustrative as I have intended it to be, and then happy to discuss any question either right now or later on.